Hi guys, there was a question from section 1.1. I just did two of them for you a minute ago, number 23 and 33, but there was also a question about number 22. So this is actually a good one because the last two that I made for you, in that case, both limit existed, because remember I was talking about on your graph, if there is no jump or hold or break, then usually the value of the function is a limit. So in this case, this is actually a good one so you can see what I was talking about. So as I also mentioned, whenever they ask for the limit as x approaches a number, they usually ask for the left-hand side limit and right-hand side limits, because remember there are two conditions must be true for the limit to exist. The left and the right-hand side limits must exist, but they must also be equal. So I believe in this case, they will both exist, but it's just they're not going to be the same, okay? So let's just start with the limit as x approaches 3 from the left. So this is, of course, our x value of 3. So we're going to come from its left side. So as you approach it this way, what I suggest, take a couple of values close to 3 and then go hit the graph, go across or your y-axis and see what are the y values are approaching, okay? So let's say we start from here, hit the graph, go across. So that's your first y value, get a little closer to 3. Again, go across. As you can see, as you get closer and closer to 3 from the left, the y values are approaching number 1. So that, of course, becomes what we call the left-hand side limit. On the other hand, as we approach 3 from the right, so this time we come in this way. So we're going to take values to the right. And again, but of course, you want to be close to 3. You don't want to start here. So when you're very close to 3, but to its right, let's go find the y value. Okay, so let's start here. We go hit the graph, go across. There's the first y value. Get a little closer. Go hit the y value. Y-axis, there's another y value. Again, as you get closer, you can see the y value this time approaching number 2. So therefore, the right-hand side limit is 2. So this time you can see actually both exist, the left-hand side limit and the right-hand side limit as x approaches 3. But the problem is they're not the same value. So anytime this phenomenon happens, as I mentioned before, this only happens when there is a jump on your graph, right? So at 3, as you can see at 3, there is a jump, and that's why this happened. So in this case, all we can say is the limit as x approaches 3 itself, of course, is DNE, right? Which stands for does not exist. By the way, on the exam also, anytime the limit doesn't exist, you can just say DNE, so you don't have to write does not exist, all the words. So DNE is fine. Everybody understand what that means, okay? So in this case, our limit doesn't exist because the left-hand side and right-hand side limit are not the same value. They're different values. So if you read your section carefully, you'll see that they talk about the relationship between the limit and the left-hand right-hand side limit, okay? So they both must exist. In this case, they do, but they must also be the same value, which is what they fail in this case to be. And that, of course, was caused by the break on the graph, okay? All right.